What you are looking at now is original raw film footage of the Mission Operation Control Room at NASA's Manned Spacecraft Center in Houston, taken in October 1970. This was 15 months after the Apollo 11 lunar landing mission and several months before the launch of Apollo 14. The display consoles you see were part of the massive control center designed and implemented by Philco Ford Corporation. Philco Ford was a subsidiary of Ford Motor Company. Philco had been highly involved in electronics, computers, satellites, and defense work for the government since the 1950s. It was purchased by Ford in 1961. In 1963, Philco won the bid to become NASA's prime contractor for development of the control center and related support activity. The control center was operational by 1965. During NASA missions, over 1,500 elements of telemetry data flowed into the center simultaneously. Telemetry included measurements of the astronauts' vital signs, spacecraft instrumentation readouts, flight data measurements, and other information. This screen display shows cabin pressure and temperature, astronaut suit pressure, heart rate, and many other factors. The Mission Control Center had two primary rooms, nicknamed MOCR 1 and MOCR 2. They housed 60,000 miles of wire and the largest assembly of monitoring and switching equipment in the world. Data from 5 IBM System 360 Model 75 mainframe computers housed in the nearby RTCC, or Real-Time Computer Complex, was sent to more than 1,300 indicator switches being monitored by mission flight controllers. Next to the RTCC was the CCATS room, housing 3 UNIVAC 494 real-time computers. CCATS stood for Communications Command and Telemetry System. CCATS connected the Mission Control Center to the Space Tracking and Data Acquisition Network, the Manned Space Flight Network, the NASA Communications, NASCOM Network, the Apollo Launch Data System, and the Deep Space Network. Every voice communication, telemetry signal, tracking data, and spacecraft command went through the CCATS. The Restoration Project. Mission Control Center controlled Gemini, Apollo, Skylab, and Space Shuttle flights up to 1998. Sadly, the control rooms fell into disrepair over time. In 2016, retired Historic Mission Control Operations team members worked with Space Center Houston to secure the resources needed to restore the mission control site. The massive restoration project was completed in June 2019.
This is Mission Control, Houston, where all the basic decisions are made during an Apollo mission. From here, flight controllers direct a mission from the time the spacecraft is launched until it is recovered. This is the focal point for all critical information on the spacecraft and the flight crew, where real-time decisions must be constantly made. It is also from here that the world gets news firsthand and can follow the progress of a flight almost as fast as it's happening.
Hey, Houston, we've had a problem here.
Can say again, please.
Houston, we've had a problem. Apollo 11, this is Houston at 1 minute. Trajectory and guidance look good, and the stage is good. Over.
Yeah, Houston, Apollo 11, that Saturn gave us a magnificent ride.
Roger, 11, we'll pass that on, and it certainly looks like you're well on your way now. Apollo 11, this is Houston. For your information, we expect the maneuver to separation attitude to begin at 3 plus 05 plus 03.
Roger. Time to begin maneuver is 3:05 03, complete 309.
Roger, that separation should be 3 plus 1, 5, 03. My error in reading up.
Roger.
Apollo 11, this is Houston. All the booster functions are proceeding normally. The sequencing is in good shape, and it doesn't look like they're having any problems at all. Over.
Roger.
Apollo 11, this is Houston. Over.
Hello, Houston. This is Apollo 11. I'm reading you loud and clear. Go ahead, over.
Roger, 11, this is Houston. We had to shift stations. We weren't reading you through Goldstone.
At 3 hours 46 minutes, velocity is 18,917 feet per second. Distance from Earth, 9,002 nautical miles.
There are 2 control rooms. Each can be used independently, and a separate mission can be handled in each at the same time. The network of tracking stations and the Mission Control Center are joined by the Communications, Command, and Telemetry System. This message-carrying system is the communications link between the spacecraft and the ground. During the Apollo mission, the main Mission Operations Control Room is supported by 6 nearby staff support rooms. In these rooms, men keep close tabs on the various systems of the spacecraft. They check the information flowing in and establish trends for long-term performance. Throughout the mission, flight controllers constantly check and analyze the status of the spacecraft. Are all systems operating within pre-established limits? Are mission events occurring as planned? The physical conditions of the flight crew are also of prime concern. Are respiration rates normal? Should the astronauts drink more water?
You got it up there, Gun?
Yeah, I got it. That looks pretty good.
Okay, I want to go to
How do you digital?
The real-time computing complex provides flight controllers with the display information they need to make recommendations concerning the flight crew and the spacecraft. Mission Control, through its vast communications and computing resources, finally directs the recovery of the flight crew.
Okay.
Aircraft and ships.
Now we got the selected
Go ahead,
AGC source for high speed from Canaries, and that's reading 107.3 by 101.
Will you say
So we
it
got
again,
a 5.
please?
They're both.
The control of an Apollo mission, be it an Earth orbital flight or a trip to the moon, takes place in this room. Success depends on the flight controllers and the critical real-time decisions they must make for the astronauts and their spacecraft.
We agree. Right on to. Okay. Vital yaw.
Go ahead.
How's it look for nominals, George?
Go with the nominals.
Roger that.
100%.
You bet.
We're home.